long-proven fact of the increment of surface temperature, generally known as global warming, has resulted in many noticeable effects, from sea levels rising to higher frequency of devastating natural phenomena. We have already seen various effects of global warming. For example, the recent abnormal winter storms, flooding, hurricanes, and tornadoes can be traced to a critical imbalance of the Earth's system, triggered by an increment of the concentration of greenhouse gases, especially CO2 and methane, both directly linked with human activities. All three states of matter expand when heated. The atoms themselves do not expand, but the volume they take up does. When a solid is heated, its atoms vibrate faster about their fixed points. The relative increase in the size of solids when heated is therefore small, but it could be significant in liquids and gases. The impact of global warming on Earth's system can be visualized in the chart shown. A superficial analysis of this figure allows us to conclude that at some point, the global warming will result in a direct expansion of the atmosphere. It is our working hypothesis that ionospheric peak height at some point will be impacted because of global warming. To prove this, we will be processing and analyzing ionospheric data for a long series. The station we have selected is Point Arguello. We are processing HMF2, which is the height of the peak concentration of the ionosphere in kilometers. Currently, we have processed the data from 2006 to 2021. To detect if global warming does have an impact on the ionospheric peak height, we are actively working on processing a longer period of data.
I conducted the necessary HMF2 research for the years 2008 and 2012. In February of 2008, we can find values such as 489.2 at 7 a.m., with the highest average of HMF2 being 349.7. The lowest average value of HMF2 was at 4 p.m. with 247.53. It decreased 102.16 points from the highest average. If we look at the standard deviation, we can see how the values are higher from the beginning of the day to 8 a.m. And after 9 a.m., we start seeing a decrease. In April, of the data accumulated for 2012, we can find the highest average of HMF2 is 361.86, which occurred at 8 a.m. The highest value of HMF2 we can see during the time is 420.5. The lowest average in April was 255.3, which occurred at 3 p.m. There is a difference of 106.56 between the lowest and highest values of HMF2. Finally, we can look at the standard deviation. We can observe a curve like an increase where the value starts low, peaks around the middle, and goes back down. Subsequently, in 2012, there was no available data from October 14th to the end of the year.
I would like to start off by stating that there was no available data for the month of September in 2009. With that being said, I have discovered a fluctuating pattern for the HMF2 values in the year of 2009. There was a noticeable gap between the averages for both the time ranges of 12 a.m. to 9 a.m. and 10 a.m. to 1 p.m. For instance, in November 2009, the average value for each hour between 12 a.m. to 9 a.m. all remained above 250 with a maximum of about 309.34 at 12 a.m., while the average values between 10 a.m. to 1 p.m. all remained below 220 with a minimum value of about 213.53 at 11 a.m. The difference in averages between the two intervals of time ranged from 30 to a total of 96 points. To summarize, the average peak values between 10 a.m. to 1 p.m. showed a significant decrease compared to the values between 12 a.m. to 9 a.m.
The work that the Miami-Dade College Space Weather Research Team has shown here corresponds to a period of at least 20 years of data in order to understand and clarify the impact of climate change, specifically global warming, on the atmosphere of the planet. Specifically, we are looking at how the increase of global temperature has impacted the ionosphere, the only charged layer of the atmosphere, where all the current systems in the planet closed, and therefore is the interface between our planet and the space. The condition of the ionosphere, being the only charged layer, as mentioned before, interacting directly with the solar wind, that is very important for technology and humanity at large. That is what our team is trying to clarify. As of this moment, we have no strong fact-based conclusion to share, but we will keep adding years to this period, and pretty soon the team will be able to have a strong assessment on the trends of the peak of the ionosphere. Thank you